Section 10.2, we're going to take a look at the rational numbers as exponents. Now the word rational for us, if you remember, rational means basically fractions. Okay, so when we say we have a rational number, that means we have a number that is a fraction. So here is actually the relationship between rational exponents. That would be a rational exponent a to 1 over n, and its relationship to the radical. So this is how it's written. Okay, so if we have a number that is an exponential form and the exponent is a fraction, this is how it's going to look like. Now it's important that this is 1 over n. Okay, the more general form of this would be the following, where we have a to the m over n, and that we can rewrite it as the nth root of a to the mth power, or we can also write it as the nth root of a to the m. Both of those are permissible. Okay, now in this example, of course, remember n has to be 2, 3, 4 and so on, right? Because n was the index of the radical expression. So n has to be a natural number, and in fact so is m. Okay, now this property of radicals actually allows us to understand numbers like this. Let's say, for example, I have something like 25 to 3/2, and I want to know what number is that. So if I rewrite, so notice, look at this is in the form that it is. So here m is the numerator of the fraction, n is the denominator. So when we put it back together, here's the radical form. A is of course this number, that's a. 25, the index is 2, and we're going to raise that to the third power, or we can write it as index 2 of 25 cubed. Now, if you think about this, so for one thing, the fact that the index is 2, that means the square root, right? Remember, in our previous lecture, we mentioned that for the square roots, index is 2, but we don't write it. So the first expression here becomes the square root of 25, which is 5, and then you cube it. 5 cubed is 125. Now, this is the answer, but we can also do this. Now, in order to do this, I need to cube the 25. Okay, so 25 cubed. Notice for this, I need to have a calculator. And I do, and that's 15,625. That's what I get. Now, if I take the square root of that number, it's going to be 125. So notice the advantage of one over the other. The first one, I didn't need really a calculator because I can do square root of 25 without it. But in the second instance, I needed anyway. You may not, but I did. 25 cubed is 15,625. That would be kind of a stretch to do it in your head. Okay. So there we have it, and so the key relationship is what's up here, what shows in here, right here. That's the key relationship between them. Now again, which of these two versions do we use depends on the expression that's given. Okay. Now, because we're working with rational exponents, these fractions in the exponents could be negative. So let's recall the negative exponent rule in here. This is from negative exponent rule. Okay, now this actually comes from the rules of exponents that you're already familiar with, but if in case you've forgotten it, this is what it says. A to negative m over n is going to be 1 over a to m over n. So in other words, we just write it as a reciprocal and change negative to a positive. Okay. And there we have it. So we should be able now to handle negative exponents, right? So for example, to see immediately, let's say I have 16 to negative 1/2. What number is that? Well, first I need to rewrite it with a positive exponent. And then looking at the relationship between rational exponents and radicals, the one we're going to use for this one is that right there. A to 1 over n is the nth root of a. Okay. Well, and by the way, there is actually an association between these two expressions. Okay. Here, m in here is 1. So if you replace m with 1, you get this expression. So you really don't need two separate expressions. Okay. You can just remember this one. Okay. And that suffices. That's good enough. You don't need to know the other one. So 16 to 1/2, m is 1, n is 2. Now 16 to 1/2, I can rewrite it as 1 over index 2 of 16. Remember, that's simply square root of 16, which is 4. The answer is 1/4. Okay, and that's the other thing. Now in this section, they also recall the laws of exponents, but if you need them, I remind you of those. The only thing that I reminded you of that we needed is this one. We call it the negative exponent rule. Okay, so let's go to the exercises and actually try to do some of these exercises here together. Okay, so let's begin with exercise number 16. In exercise number 16, we are given 125 to 1/3 power. And the question reads, write an equivalent expression using radical notation and if possible simplify. So we're going to rewrite it in radical notation. Again, if you want, m is 1 and n is 3, the denominator of the fraction. So here's n, here's 125. And if you need to write that numerator m1, that's where it goes in the radical form. Okay. Usually if we raise to a power, we don't put the 1 in there. So all said and done, all I have to do is take cube root of 125, and that's going to be 5. Since 5 by 5 by 5 is 125. Okay. So there's your number 16 for you. Let's take a look at number 28, for instance. In number 28, I have 4 to 7/2. So again, in this one, m, the numerator, and the denominator. Here's the n. The denominator becomes the index. Then you write a, the base, in the exponential form. And then, of course, 7. 7 goes on the outside. Notice this is much easier to do than the alternative is write it as a square root of 4 to the 7th. Square root of 4 is 2. The answer is 2 to the 7th power. With this option, now again, I have to use my calculator and determine what is 4 to the 7th power, right? That's what I need to do. And I just did in case you want to know. You see that? We're trying to avoid this. So that's really not what I want to do. And square root of that is going to be, square root of that number is 128. Now we can get the same answer by doing 2 to the 7th power, right? 2, 3, 4, 5, 6, 7. Right? That's what 2 to the 7th mean. 2, 2, 2. Well, that's going to be 8. 2 by 2 by 2 by 2. 2 by 2 by 2 is 8. And then times 2, 8 and 8, 64. Times 2, and that's 128. So you get the same result, right? Okay, and that was number 28 for you. Now let's take a look at another one. I'm gonna try number 36. In exercise number 36, we are given the fourth root of 10. And this time we want to write an equivalent expression using exponential notation. Okay, so if you want, you can assume that this is raised to the first power, so I can use the special function we had in the beginning of the video. So in this case, again, m is 1 and n, the index is 4. So this is going to be 10 to 1/4. And there you have it. We're done with that one. Because we just want to rewrite it, that's why. In number 40, what do we have? We have square root of a cubed. Now here's where it's important to, if you want, put the index 2 here. Okay, put your index 2 and rewrite it now as a to the m over n. Index is 2n. M is 3, index 2. So a to 3/2 looks reasonable. Let's take a look at another one. So for instance, let's say we'll look at number 48. In number 48, I have cube root of 7xy to the 4th power, and I can rewrite that as, okay, so here's my 7xy. Question is, what is the exponent, right? The fraction in the exponent. So here again, m is 4, n, the index is 3. And remember, our form of fraction is m over n, so 4/3, right? That's what's going to go here. That's the rewrite of that one. Okay, now let's take a look at something like number 54. In number 54, I have 10,000 to negative 1/4. Okay, so the negative exponent rule kicks in, so that's going to be 1 over 10,000 to positive 1/4. So here's 1 over. Now, 10,000 to 1/4. Remember, the denominator is n, the index in the radical. So it's going to be 4th root of 10,000. And the 4th root of 10,000 is just 10, because 10 multiplied by itself 4 times gives you 10,000. So this answer is 1/10. Something like number 58, I have 1/8 to the exponent negative 2/3. Now there's actually another property of exponents. Let me give it to you that comes in really handy for these types, like number 58. And here's what that is. If you have, let's say, a over b to negative m over n, you can simply flip the fraction, write it as b over a, and change negative m over n to simply m over n. Okay, and there you go. So if I employ this property, then I can actually rewrite this as 8 over 1 to positive 2/3. Now 8 over 1 is just 8, isn't it? Any number divided by 1 is itself. So that's just 8 to 2/3 exponent. Now, to 2/3 exponent, so again, rewrite it in radical form. The denominator becomes the index. The numerator becomes the power on the radical. Cube root of 8 is 2, and 2 squared is 4. Okay, and there we have this one, number 58. And let's see, anything else here? I'm just browsing here. Okay, let's go all the way to number 84. In number 84, we want to do the 12th root of a cubed. Okay, In this one, the instructions are use rational exponents to simplify. Rational exponents means we need to rewrite it as a fraction on an exponent. And then write answers using radical notation once we do. Do not use fractional exponents in the answer. So that means we want to go back to the radical form. So if I understood this correctly, this is what we need to do. A to 312. Remember, this is M and this is N in that general conversion we had in the beginning, the formula we had in the beginning. Now A to 312, well, 312 reduces to 1/4, doesn't it? Now the question reads again. It reads, do not use fraction exponents in any answer. So they don't like this answer. So index 4 of A. That's the final answer on this one. That's how they want the answer. Let's take a look at another one. Boy, we did a lot of these together, huh? Number 92. I'm doing the 8th root of 3x quantity squared. Again, this is M and this is N. So that's going to be 3x to M over N. That's 3x to 1/4. And then they say they don't like fractional exponents. They want answers in radical form. So that's going to be the 4th root of simply 3x. Okay. And there you have it. I think we're good enough on this. So we're done with this section, folks. That wasn't too bad, I don't think. And the lecture didn't take long. It's only about 17-18 minutes, right? So hopefully you're able to follow these. Please do try some of these exercises and see how things turn out, okay? And with that, we are done with this lecture.